So we launched this whole webinar series to try to get people together, give us an opportunity to talk about some of the things of importance to us in the measurement industry, and give an opportunity to just present some information and stimulate some discussion. So we especially looked at this too right now because from the perspective of us, from Insight Analytical's perspective, we've changed a lot over the years. We launched about 5 years ago to bring a new technology to Canada as a company called JP3 Measurement. And sorry, I'm the one person who always forgets to turn the volume off on my phone in a meeting. There we go. So we launched about 5 years ago, brought this company into Canada, and have helped develop some markets there. But at the same time, we've grown a business and added people and added new products. I've been really blessed in this whole COVID period. We've actually managed to grow. We increased our staff by about 50% from about 10 to 15 people, added on a bunch of new product lines. And a lot of this online thing has helped to make that work. Okay, so I want to start off a little bit about what we're going to talk about today. We're going to give you a little brief introduction to Insight. We are a Calgary-based company. Run in Northeast Calgary, have a fairly large shop, 10,000 square feet with another 10,000 square foot manufacturing floor attached. Great access, and we basically are a systems integrator, product developer, and a manufacturer's representation or representative. So I want to talk a lot today about what's new and what products and applications we're serving, and then talk a little bit about where we're going next and what we're doing. One of the things we really got established doing was doing systems integration. As I might have mentioned, I teach a course on sample system design, so we're pretty good at doing analyzer sample systems. And it's a big part of what makes analyzer systems works. So we bring together full systems integration capabilities. We'll do everything from small custom sample systems like just a regulator or a pressure reduction panel, to process analyzer integration, to PLCs and automation packages, to doing full analyzer buildings. And so it's really, we kind of look at it as no project too big, too small. We do everything on that integration side, from front-end engineering design. We just finished up a project with Flint Hills. We'll go from the feed side of that into detail engineering and design, to full fabrication at our facilities here, install and commissioning, and of course, everything we do, service is kind of the mainstay of what we do. We have full-time service out of Calgary, out of Edmonton, out of Grand Prairie, and when we can travel, like to send our service people to all of our principals and make sure they get factory trained. So if we sell it, we want to be able to service and maintain it for you. One of the big product lines for us, one of the ones, like I said, that sort of founded the company, is the JP3 analyzers, VRX analyzers. And these are near infrared spectrometers. I've done a number of webinars about these. There's a few of them up on YouTube. So if you're really interested in a lot of details about this, we can certainly get that information to you. The big thing about these are near infrared analyzers that do what we would traditionally think of doing with something like a gas chromatograph or an online physical properties analyzer. You say, well, why would I want to not just use a gas chromatograph or an online physical properties analyzer? Well, because these devices tend to have much larger flow paths, they can deal with dirty, contaminated samples a lot easier. And it makes a big difference. People think because someone calls it the same application, it's the same thing. So this guy over here is a sample of natural gas condensate off of a debutanizer. It's nice, it's crystal clear. You can just about run your lawnmower off of this. This guy is natural gas condensate as well. It's dirty, it's waxy, it's got asphaltenes in it, and it's really hard to run through a sample system. So in certain applications, we want to use technologies that are going to better be able to operate in that sort of environment. The thing that the JP3 does, this is the kind of flow cell that it runs through. And the thing that it does is allows for these nice large flow paths, half-inch ports, doesn't plug off easily. So again, we like to look for products that are going to be low maintenance when they're installed. Big time applications for this: condensate stabilizers at gas plants or at oil production facilities in the US. You know, what they call oil is like heavy condensate for us. Crude oil blending, vapor pressure blending. So the skid that you see, or the panel that you see right over here, is at a crude oil blending skid. You can see the 4-inch pipe running over the top and over the bottom. And in the middle there, the white box is a little JP3 analyzer. The box towards the center of that with the gray covering on it is where the near infrared cell is. And we're flowing a sample of the crude oil through that near infrared cell and doing real-time measurements of vapor pressure. In Canada, a lot of our oil is fairly heavy, and so we're allowed to mix butane in with the oil, as long as we hit the vapor pressure spec. So if we can sell cheap butane as if it's crude oil, it's like watering down the whiskey, something we don't like anybody to do to us, but there's a good way to make money at doing it. Pipeline quality analysis, especially transmix, has been a big application as well for that. Vapor pressure and also detecting the interface between products. And then, of course, just whole gas plant optimizations, the ability to measure across a full frac plant. One of the product lines that we brought on recently has been the cosa+xentaur line. And one of the big parts of that line is the analyzer you see here, which is essentially a wobbe index analyzer. So we always think about the heat content of fuels and BTU. Oh, sorry, Tim.
Can I interrupt you for a question real quick? Did you see the one from Tim?
Yeah.
Is the optic sensor self-cleaning, or how often does this optic sensor need to be cleaned?
It's a great question, actually. Appreciate it, because it's one of the things that we found very advantageous with this technology. We've been in crude oil applications where we had a client who was running for 9 months. We were worried that maybe they weren't even looking at the data because we hadn't had any feedback from them. And they phoned my service technician on a Sunday and said, "We just lost Modbus communications to the analyzer and we can't blend without it. So can you figure out why we lost communications?" Can run for extended periods of time. It is a bit application dependent. Some condensates are really waxy. And so one of the things that we do is we try to keep the cell hotter than the process stream we're trying to measure. That helps things like waxes not precipitate out on there. And in some applications, we've introduced a toluene backflush system where when the amount of light that goes through the cell drops down, the system automatically back purges with toluene to clean all that wax off the system. So it's a bit application dependent, but generally we see single-digit months to many months between cell cleanings. And cell cleaning is literally 4 bolts off on each side and you got the cell open. For Canadians as well, we do all our measurement at line pressure. So CRN is to 1500 PSI. So we have, we can go on a full 600-pound ANSI class system with no PSVs or anything like that.
Phil, can I interrupt for another question?
Yeah, sure.
On the previous slide, you briefly mentioned the transmix. For crude oil blending, I believe it's possible to use a JP3 NIR for particulates. And in theory, you may be able to use acoustic spectroscopy from the transmix to do the same thing. What do you, in your opinion, what do you think would be a better application for, or I should say a better technology for particulates in crude?
So with the or any kind of optical system, the difficulty sometimes of doing particulate is they don't give you a nice absorption spectrum shape. They tend to just block a lot of light, and so what you get is a big baseline shift. And so with optical techniques, they often use a derivative spectroscopy, and so it gets that DC offset out. That's a place where acoustic actually might be a better approach for trying to do high levels of particulate than, say, using an optical system that's trying to look at the shape of the spectrum. When we've been looking at transmix, we've more been looking at things like pipelines where they batch their samples. So we're going to run jet fuel for a while, and then we're going to run gasoline, and then we're going to run diesel. And we look at it to get a spectral interface for, okay, the mix is now such that I can sell this product as diesel. For the last little period of time was a mixture of jet fuel and diesel. And again, we're going to talk about perceptive sensors in a little bit and the ability that you can do that sort of measurement with acoustic systems as well. So, yeah, satisfy that? Okay, good. So again, with natural gas and things like that, we think about BTU value. We think about how many calories are in there. But when we're trying to control a burner, the amount of flow that goes through an orifice changes with the specific gravity of the fluid. So wobbe index is a ratio of really the heat content to the square root of the specific gravity. And it allows us to do tight burner control. It lets us get the most efficiency out of the fuel with the least environmental emissions, lower NOx burners. So typical applications we see for this technology is things like in Alberta, certainly at SAGD on steam generators. We want to get that air to fuel ratio right, especially if we're getting fuel that can sometimes come in fairly rich and hot. Similarly for gas turbines. Gas turbines don't like to see drops of liquids come in with them or really rich fuels all of a sudden. So if they do, they can get too hot and it can damage the turbine blades. So typical application is burner control, where we're either doing fuel blending or trying to control large burners like turbines and SAGD steam generators. And we want to get the best efficiency as possible. Big features about this is an industry proven method. Probably the most accepted method for doing wobbe index is this residual oxygen method. Gives us really fast response, has a wide measurement range, and low maintenance compared to some other methodologies to try to do this. What we really do is we take a sample, we burn it, we see how much oxygen is consumed, and from that we correlate that to, well, how's it going to burn once it gets into my steam generator or my turbine. Another optical technology, my background, I'm a spectroscopist by trade, so you'll see that a lot of the technologies that we look at have been are optically based. And one of those is a company called MARQMETRIX. These guys came out of the Center for Process Analytical Chemistry out of Washington State. And they developed some unique features on Raman spectroscopy. This is a fascinating thing from a physicist's perspective, because a physicist named Dr. Raman from India predicted that this spectroscopy could be done if anybody ever developed something like a laser. And then when the laser was developed, they actually started doing it. And so it's kind of cool because he anticipated this technology coming when other technologies became available. Applications for this include doing full natural gas composition with inerts and with things like hydrogen. And so this is becoming important because as the world's looking towards greener energy sources, people are starting to blend hydrogen into natural gas. And a lot of the existing gas chromatographs that are out there can't make that hydrogen measurement without significant modification. And so this is a technology that can give us a very fast analysis of a natural gas stream, do the C1 through C6 hydrocarbons, and to do the hydrogen, nitrogen, oxygens. We can use it for things like amine acid gas, doing CO2, H2S, water vapor, and hydrocarbons, natural gas liquids, methanol in what the US calls Y grade, what we call a C3 plus stream. But people often want to know their methanol in their LPG. And methanol has a nice unique peak in the Raman that lets us do trace methanol measurements. It's kind of something you don't want to try saying too many times in a row. Again, big feature, I should have mentioned this on here as well. No moving parts. A lot of these optical technologies have the advantage that they have no moving parts. So from that perspective, they can be very low maintenance. They tend to be very fast response. And this is a fairly small device. The probe sits into a T or a fitting like this and has process fluid going by at line temperatures and line pressures again. So it's another optical method by which we can make these measurements fast with very low maintenance. I'm just going to pop up a little natural gas or it looks almost like a chromatograph. But this is the Raman spectra for natural gas. And so, we see unique peaks from a lot of these species. You see the propane peak, the ethane peak. This is hydrogen way over here on the side, on the far right. And so we can go through and do this analysis of a bunch of these different chemical species based on very unique peaks. So it makes the algorithms a lot of times, spectroscopic systems require fancy mathematical algorithms we call chemometrics to do the analysis. This makes that analysis a lot easier when we have nice unique peaks like this. Going away from the analytical side for a minute, we also work a lot with the instrumentation side, and especially with Level, and especially with Hawk. Hawk is an Australian company that developed a lot of their technology for the Australian mining industry and the oil and gas industry in Australia, and built a lot of product following and a lot of product capabilities close to home, and is now expanding internationally. And we have the privilege of being Hawk's distributor in Western Canada, and they have a number of Hawk products that we're going to talk about along the way. One of the big things they do is level measurement, and we're going to talk about multiple different level technologies. People often think that you can take one technology and try to fit it into multiple applications, but in many cases we find that using a different way of trying to measure the same thing can give us some measurement advantages. And one of the devices that Hawk has is a guided wave radar-based level sensor. Principal applications have been in the mining and mineral processing industry, but also in the oil, NGL processing terminals, any place where we're kind of trying to store things in either barrels or tanks or vessels. We can use this technology as a level measurement. The important thing about it is we can do two level measurements with it. So if there's an interface, like condensate sitting on top of water or oil-water interfaces, we can get the interface level and the overall level of the tank. And so it allows us to determine, well, how full is the tank, but is there something in there that's maybe not the thing I was really looking to measure?
Hey, a quick question with that guided wave there. For the interface, is there a dead zone in between? Do you know what the approximate measurement is on that?
It's pretty small. It's pretty tight. It depends a little bit on the differences in the density and dielectric constants of the fluids that are there. But it's, we can usually get down to within inches at least.
3 millimeters.
Yeah. 3 millimeters, is that the spectrum?
3 millimeters. Yeah.
Oh, I also see from Vim, is it Vim? Probably the Netherlands, Vim, yeah, I think. CH components, measure separately as a Raman C5, yeah, we typically do speciation up to the C4s, then do a composite C5 and a composite C6. One of the other interesting things that Hawk has been doing is bringing out their devices with power over Ethernet, which means that we can start to have if you have a tank farm, we can distribute out these pressure or these level sensors, run Ethernet out to them and be getting data off of that as well as getting power. And along with that, they've launched a product called Hawk 365, which allows continuous monitoring of those and putting that data up to the web.
Sorry.
No worries. Oops, actually, Chelsea, I think we have a poll for you. So one of the things that we're doing, as I go through this presentation, by the way, we're planning this webinar series this is going to be a weekly to bi-weekly sort of thing, depending on what other training I'm doing. And because we have a lot of product lines we're going to talk about today, we'd like to ask for your help. So as I go through about 4 or 5 products, we're just going to put up this little poll that we're going to ask you to answer, which is going to say kind of, if we were going to do a webinar that goes into a lot of detail about a particular product line, which lines of most interest you of the last 4 or 5 things I talked about?
And there's the first one.
Thanks, Chelsea.
You're welcome.
And to once more tip my hat to my friend, Mr. David Luco. If you do come over to the shop for a visit, we usually do have a decent scotch kicking around, by the way.
Going to depend on when we're allowed to visit, being in jail with COVID, right?
I know. As soon as you're free, Dave, phone me.
Well, I'm looking forward to when we get day parole.
Yeah, day parole. There you go. Yeah.
But we have about 16 out of the 22.
Let's
Yeah,
call that.
Just move forward. Okay, cool.
Yeah, sure.
All right.
Cool.
And-
So it looks interesting. See, this does a spectroscopist's heart good, is when the two technologies that people are most interested in hearing about are a couple of the spectroscopy based ones. So that's great info. Thanks for that feedback. I will mention we have done JP3 a few times. And when Scott or Chris sends out an email, we can put a link up to a couple of the YouTubes that are up there about JP3. We are planning a big one with JP3 in March. We did one in December, and so we'll also advise you of those upcoming ones as well.
Cool. Thanks.
All right, I think we can.
I moved.
Well, did you share the results?
Yeah, I did. Is that okay?
Yeah, that's perfect.
Yeah, good.
Good. Cool. All right, so moving on. Along with representing other people's product lines, we like to develop some of the things of our own. And one of those, a large midstream company here in Alberta came to us and said, you know, we're really interested in getting composite samplers for our C3 plus streams, our C5 plus streams for our crude oils that meet a bunch of specific Canadian requirements.
I think we have to go. I think we have to go.
Okay. We did, so they came to us and said, look, we want these composite samplers that meet a bunch of Canadian requirements like CRA and CSA, but are completely customizable as well for different applications. And so we designed these liquid composite samplers. So when you look at one of these, you'll typically see a large accumulator vessel like the one that you see over there. That slowly gets filled over a period of time. It might be days, weeks, even a month in certain applications. And what it does is it provides a composite or an average sample of the fluid that's been flowing by. So what we do is we go on a pipeline, for example, and say, well, for every 50 barrels that goes by, let's put a milliliter into that accumulator vessel and fill it up over the space of a month. We have another client who loads propane onto ships to go to Japan and says, well, as I load my ship, it takes me about 3.5 days to load my ship. I want to fill this vessel up over the 3.5 days. And the average that is built up in that vessel represents the average of what got put onto that ship. And we've done a fair number of unique things about there, especially we're very cognizant of the American Petroleum Institute's API 8.2, which describes about a lot of things about just how to do this right. We basically made sure we wanted to do this right, make it really easy to operate as well. So one of the things we do with a lot of our sample systems is we'll try to do things like use color-coded valves like you see there, so that when we write an operational procedure of how to do a certain operation, it's easier for operators to just look and say, oh, I'm supposed to turn the round red valve. That makes life easy. And so we try to consider this from a field operator's perspective and how they would go about trying to use these devices. And we have a big project on the go right now, which we think is going to be about 20 of these. We've got a number of these installed out in the field with a number of different companies. Again, these are liquids composites, so as compared to gas composites. So these are for propane, C5 plus natural gas condensate with the US often calls natural gasoline and crude oil type applications. We have a great strategic and practical partnership with Sulfur Experts. Sulfur Experts is a consulting company which does work all over the world, optimizing gas plants, natural gas dehydration systems, amine units, and sulfur recovery plants. And so because our client base overlaps so much, it's a real opportunity for us. Sometimes people are in a position where perhaps an analyzer isn't the most cost-effective thing that they need. What they need is someone to come in, test their plant, and say, this is the better operating point for you. So they use some of our automated sampling technology, and we use their process and technical expertise to help our clients operate better while also assessing what's the best product that's going to meet their needs. When we were talking about transmix, this is a really interesting new technology that's come out of the US, a company called Perceptive Sensor Technologies. And they use a technique called acoustic fingerprinting. It's basically using ultrasonic sound to make measurements inside of a vessel. This technology was originally developed by the US military. And the purpose was to be able to take a shell when they're in the Middle East and some conflict situations, be able to take a shell and try to identify whether the shell possibly had nerve agents or chemical warfare agents inside the shell. And so the thing about acoustics is we can put it on the outside of a pipe or the outside of a vessel, let the sound waves travel through the vessel, and then identify based on the speed of sound and some of the other acoustic properties, what fluids are in there. So we can use this to identify components in a tank, put a sensor beside the tank, say, oh, this one's got LPG in it. Oh, this one's got butane in it. We can look at it for transmix and pipelines again. As product changes, speed of sound, if you change the density and some of the other properties of the material, the speed of sound changes and the acoustic property changes. Big thing about this is it's a non-intrusive installation. We don't have to put a probe in. We don't take any fluid out of the pipe. And so we can implement this technology without making a lot of changes on site. One of the interesting applications of this came up from API 2350. And this was a new set of regulations that came out about how much you can fill a storage tank. So traditionally, people are going to have level sensors installed that go into the pipe. They've actually made a penetration into the pipe and they measure the level by having some kind of sensor and they're in contact with the fluid. Based on the size of the tank and the size of the pump that was feeding into it, so I'm going to draw a little pump over here. Based on the size of the tank and the size of the pipe that was feeding into it, API 2350 said, well, you're only allowed to fill the tank to a certain level. And this meant that a lot of these big, if we have a 200,000 barrel storage tank, it's often only filled to 150 or 160,000 barrels. The modification that came out with API 2350 was that if you could add in an additional level sensor based on a different technology and not on the same data communications network as a high level sensor, you could increase the amount you could fill that tank to. So the beauty about this technology is it doesn't have to penetrate the tank. So you can add that additional level sensing capability in and increase the storage capacity of existing storage tanks. There's also a device which we refer to as portable ID, and it is basically a little suitcase with a sensor that we can put on the side of a tank, have a library of chemicals it's calibrated for, and say, well, this tank has that fluid in it. This one's a gasoline tank, this one's a diesel tank, this one's jet fuel, and you push the sensor up, press the sensor up to the side, measures the acoustic signature, and says, this is what's in that storage tank. We also work with AMETEK and Universal Analyzers with their distillation samplers, or what some people originally was called the pi gas sampler. Fluid Data came out with these long number of years back and was referred to as a pi gas sampler. The pi here is for pyrolysis. These were often pyrolysis. Somebody can correct my spelling if they like. These were developed to typically originally for ethylene furnaces and things like that. When we take ethane and we crack it to pull some hydrogen off of it and make ethylene, we can end up making a lot of carbon. And so we end up with this chemical reaction that's making a lot of carbon, and it has a lot of steam there. And these types of samplers are used to extract a sample out of that high temperature, dirty, wet sample stream, cool it, condense the water, take the particles out, and give us a sample that condense the water, take the particles out, and return them back into the process, and take a sample over the analyzer that we can use to do analytical measurements and process control. Gentleman by the name of Steve Smith was involved in the development of this, and Steve's a very smart guy, lots of practical experience, and he basically looked at the existing technologies that are available and said, if I improve the distillation tray design of these, I'm going to get better separation. If I improve the temperature control, I'm going to get better analytical accuracy. If I make it so it can be taken apart and cleaned easily, I'm going to improve my maintenance requirements. So these are great devices to consider in applications like ethylene dehydration, propylene dehydration, naphtha furnaces, cat crackers, any place where we've got high pressure wet sample streams.
Somebody have a question, guys? We heard a little something. It could have just been a little background noise, or you good? Does anybody have any questions? Phil is a fast talker.
I am a fast talker. I always run late on these, so I start to try to speed up as I go along. Yeah.
Excuse me, Phil.
Yes.
Yeah.
So one of the applications is fluidized catalytic cracking units. Are people putting these on the regenerator flue gas?
Exactly.
Okay.
Yeah, they're going on the regenerator side, and where they often have all those catalyst fines. They're just looking at one of these at I think Valero in Washington State there, and yeah, they go on that regen gas side and use this to try to deal with all that fines and the little bits of carbon that are coming off in there. Another one of the unique things that Hawk has done is taken what people have often done with, what they refer to as ultrasonic sensors, and said, if we lower the frequency and we increase the power, we can make these acoustic wave sensors that can operate in really dusty, dirty, contaminated type environments. So, as they show up here, we're looking down into a chute where tailings are coming in, and you can have lots of suspended material there and lots of open path type level sensors get confused by the dust and bits of particles that are getting raised up into the air above it. The solvent can work in extremely dirty environments, and the sensor surface, if you're ever around one of these when it's running, you hear this tap, tap, tap every once in a while, and it's them using, they mechanically vibrate that surface to try to keep it clean. And so we can go into applications where there's extremely dirty environments. Often these might be mining or plant tailings type applications. And over here you can see this, the most difficult applications is when you have some moisture there and all that particulate, because things just coat all over everything. And so underneath that mound of dirt is this salt and acoustic wave sensor. And it's still operating and making measurements in there because the self-cleaning sensor head right down at the bottom is managing to keep itself clean. And this lower frequency, high power acoustics lets us still make that level measurement.
We have a poll. for this
We
one?
do.
Are you still, I'm sorry, are you still speaking? Can I go?
I
Done? No?
am not. I am good for the poll. Thanks. So again, we're looking to try to figure out if we're going to do a future, as we do our future webinar series, we're going to try to tailor this to things that people might be more interested in. And of course, Scotty and Chris are going to be reaching out to you guys as well, which will, with some information with the line cards and that. And so if you have any questions immediately, they'll be certainly letting you know who to talk to.
There's still people answering. So just
Right on.
give it a sec.
Well, we're almost halfway in, so I think I am actually going to indulge.
Okay, we've been sitting at about 14 people for a while. So unless anybody wants to get their votes in real quick, guys, we'll probably just end this.
Perfect.
Nope. There we go.
Cool. Well, again, I like those results because there's a lot of interest in our composite samplers, and certainly for the guys who are on the production side or on the pipeline side, it's a very applicable product. And I'm interested to see that there's a lot of interest in the distillation probe. Certainly when we're looking at things, as we see that with the changes that have happened with horizontal fracking, with the U.S. Production from a place like the Permian and Marcellus, a lot of cheap ethane coming on the market, ethylene production. North America has become the best place in the world to produce ethylene, really. So an interesting set of results, and thank you very much.
Cool. Okay, done.
Awesome, thanks. Thanks, Chelsea. Okay. Oh, get my cursor over here. Still on the idea of level, there's level in ponds and in thickening applications, where we've been taking fluids and we're perhaps adding chemicals to help flocculate, to help bring particles together. We want to not overdouse these things, not use too much chemical. And so when these materials start to settle, we end up again with two different layers, kind of the liquid or the fluid that's involved, or what we often call the flock or the fluff layer, where all the stuff is starting to come together, but it's not really solid yet. And so the Hawk sonar system allows us to use a similar sonar to what you would think of as being in a submarine, where we send out a pulse of sound and we look at how it bounces back and we can tell the two different levels. And so the typical applications for this is in water and wastewater treatment, tailing ponds like we would have up in the oil sands operations, thickeners, where in mining applications where they've got large tailing ponds and they want to try to get all those fine particulates to settle. And so we can use this to control chemical dosing and provide substantial cost savings. Big thing with this is always with how you process the data. So where Hawk has made a lot of advancements is in their data processing applications and in mechanisms to try to keep that transducer clean in these applications. So again, I stress it all the time, but we're always looking at how do we optimize for maintenance as well. And so the sort of thing that we might see in these applications is, we'll have the sensor in there. Actually, this is probably got to be zoomed. We'll have the sensor in there and we get a different speed of sound and we get a bounce back from the first place off of that free settling zone. And then we go through this, what we refer to as a hindered zone, where it's not really liquids and it's not really solid yet. and we get a bounce back off the compacted zone at the bottom. And so we can look at the acoustic signals that come back and identify all of those different level points. And it allows us, if we're adding chemicals in to try to speed up that settling, it allows us to control our injection rates. Another product that we've come out with is that, people, spot sampling and grab sampling is one of the most common methods that we use to determine what's going on in a process. We go out where people go out and pull a manual sample, whether it's at a refinery, whether it's at a gas plant, whether it's on a pipeline, they go out and they pull a manual sample and they send that sample to the lab for analysis. And when we talk to people at the labs, they said the two biggest problems we have are either the person who pulled the sample didn't know how to pull a sample properly. And so if it's a volatile liquid like propane or condensate and they let bubbles escape, they get a bad sample. Or if it's butane blended crude, they get a bad sample. If they don't pull at the right speed, if they don't allow systems to purge for long enough, all of these things can lead to getting a bad sample. So labs are one of the big issues they have is people don't pull samples properly. And the second issue that they have is that people don't write down the appropriate data. What time was it when I pulled the sample? Where did I pull the sample from? What day was it? What process was I on? And so one of the things that we've done for a number of our customers is to automate those systems. So in the one that we're showing here, we have 4 floating piston cylinders that would be used for high vapor pressure samples. And you can see we've got a whole pile of valves, solenoid valves on one side, controlling pneumatic valves on the other side. And we completely control that whole fill cycle. How long does it take to fill? How and when do we actuate it? And we run that all from a PLC so that we get all those date and time stamp records, pressures, measurements. We know exactly where the sample's from. We can actually barcode each of the samples from the PLC and the interface there. And it allows us to get around a lot of those problems that are commonly associated with pulling manual samples. The other thing it does is there's health and safety implications of this too. And we talked to clients who said, well, my guy was pulling a propane sample and he forgot to close this valve as he was pulling the sample. He got liquid propane on him and things like that. So we can now automate that whole process so someone just has to go out and pick up the samples. So it makes it we don't have to do as much operator training as well. The other thing is we often want to get a sample during a plant upset. But during a plant upset, everybody is busy trying to deal with the upset and nobody can get out there to pull the sample. So in here, we just trigger the PLC, tell it we want a sample right now. We've done these for floating piston cylinders like I just showed. The ones over here are what we refer to as glycol displacement cylinders. Again, they can be used for high volatility products like butanes and pentanes. Big thing is no operator intervention, repeatable and reliable. The sample gets pulled exactly the same way every time. It's safer for operators. The PLC pulls in all of that chain of custody information. So it makes the samples that we get more useful to be submitted for lab analysis. Again, level sensing devices, and like I say, these all come about for different applications. This is kind of a unique one over here. They have what's referred to as a grizzly. It's a bunch of bars and there's gonna be product that can potentially go through there. There's gonna be a bunch of gravel, dirt, fines, rocks down there. We want to know the level. The problem with a lot of level sensors is if there's a device in between them, they pick up a reflection or they sense the level of that device. In this case, a lot of level sensors would measure how far is it to these bars. That's not what we want to know. We want to know how far below the level of those bars is the material I'm filling that tank or that bin with. And the nice thing with the Center of Free Space radars is they have a very narrow beam. We can align them such that we can make those measurements between these sorts of devices or around interfering devices. And in doing that, get a very reliable, accurate measurement of level in difficult type applications. Again, high self-cleaning sensors, high power pulses so that they can punch through things that potentially could be interferences like mist, like dust levels above there. And big thing with Hawk, again, has been a lot of algorithms to reject noise and get a precise level measurement in the midst of potentially interfering signals. Adam, for some of you may be familiar with the thermo devices, the total sulfur analyzers. Adam has brought a total sulfur measurement based on a similar measurement technique, looking at sulfur fluorescence, but they use a different type of light source. They use a thing called Nexamer, and allows for much better linearity and allows for much better interference rejection. And so we use this to do total sulfur in applications like total sulfur in natural gas, total sulfur in LNG, in diesels and other liquid fuels, so things like natural gas liquids, Y-grade, C3 plus streams, C5 plus streams. And so it allows us to do a measurement of total sulfur content. And of course, this is important to us because it's a specification on almost every hydrocarbon product that we sell. Whether it's natural gas, whether it's propane, butane, gasoline, there's a specification on total sulfur. And so we use this to do those measurements to make sure we can meet that specification. Available as both an online device and a laboratory device. Big advantages are this higher spectral purity, eliminates interferences, very fast response time, and low utility consumptions. Some of these devices will use oxygen as to help promote the conversion of the sulfur to sulfur dioxide. And the atom furnace is quite good at being able to do that with just running instrument air. So again, this is for a total sulfur measurement in hydrocarbon type fuels. We also work with SpectraSensors, tunable diode laser technology for making measurements of things like moisture, carbon dioxide, and H2S in natural gas, or in other applications where we're looking for trace moisture and trace H2S detection. Common ones have often been natural gas type applications. Also used for ammonia measurement and doing ethylene purity, acetylene measurements in ethylene. So again, going back to that chemical side of things, ethylene production. Advantages of tunable diode laser technology is, of course, high specificity with long optical paths. We can get to really low detection limits, very fast response time, no moving parts, back to that, no moving parts, low maintenance type thing. So we see these again very commonly on the natural gas processing side of the business. From the COSA side, there's also the Xentaur product line, which generally are moisture measurement devices. Two types, tunable laser spectroscopy again, and aluminum oxide based moisture sensors. So differences can be on these things can be speed of response and price, but we have a range of different moisture measurement technologies to look at specific types of applications. So when we're looking at an industrial gas dryer or something like an instrument air dryer, we'll probably move towards looking towards the aluminum oxide sensors because they're lower cost, easy to install. And when we want very high precision, mission critical type process moisture measurements, we'll look towards moving towards laser type measurements sometimes as well. So again, we've got a range of product lines for looking at these types of applications.
We actually had a poll for the last one too. So we're one
poll back? I'm sorry.
Yeah, I'm just going to
speeding through.
Really quick, guys. We know that we're coming to the end of our time, so we'll be quick. Right on. Okay, that's pretty good. So we've got 16 out of 19.
Great,
And
thank you.
show everybody.
Awesome. Cool. Definitely seeing a big focus on a lot of the analytical and analyzer side of things. It was pretty cool for an analyzer guy. Okay. All right, let's move along here. Yeah, I am running a little bit lengthy here, as usual, even though I'm talking fast. So we talked about the COSA stuff. One of the things we also do, there's been an interesting development, if you like, in gas and liquid hydrocarbon processing. And I will say, again, thank you for these polls because we're keeping these results and it's going to help us figure out our webinar approach as we go forward. So people often use a chemical called triazine to remove H2S from either gas phase or liquid phase samples. And it's become a common method of removing H2S. And when the reaction occurs, it makes a chemical called dithiazine. And there really wasn't, originally at least, no one thought there was gonna be a lot of issues with dithiazine in terms of how it would impact pipelines or other processing vessels. But as we started to use it more and more, we started to realize that this dithiazine has some unique phase behavior, and it's been seen to do things like block regulators at natural gas compressors, or when people are trying to take the methanol out of LPG, Y-grade, if they've got a deoxygenation plant, they'll find that as they try to take the methanol out, the methanol let the dithiazine stay in solution, and all of a sudden they precipitate these materials out on their trays. So it's become important to try to find a way to measure this dithiazine. The difficulty is it's often there in parts per billion type levels. And so we need some very sensitive technologies to detect it, especially in the gas phase. So Insight has developed a methodology in conjunction with Alberta Sulfur Research to use a trap type method. So on this panel, we can basically put this panel out in the field. It has a column over here that's a trap. It absorbs dithiazine over a period of time as natural gas is allowed to flow through it. Integrate the total flow rate on an integrating flow meter. Take the trap out, send it to the lab, and we do a lab analysis and say, this is how much dithiazine you absorbed when you allowed so many liters of natural gas to flow through the panel. And that lets us determine the dithiazine concentration. So we've got these now installed over a number of parts of the natural gas transmission grid, just looking for places where the dithiazine concentration is high, because those are places where we can potentially shut down compressor stations. The other thing people want to know is they say, well, I know I've got this particulate at my compressor station or at a filter, but is it dithiazine? And so if you ever watch the TV shows, you know, where the crime shows where the police have these liquid vessels and they put a sample and they go, oh, that's cocaine or that's this drug. We came up with a chemical that we can use as a similar sort of reaction. We start out with this perfectly clear fluid, as you see on I guess that's on your right as you look at the screen. And if there's no dithiazine there, it's perfectly clear and a light kind of crystally blue. And as we add even smaller amounts of that, this is 0.5 microgram of dithiazine, the solution becomes cloudier and it actually starts to try to turn to a yellowish green. And as we add more and more dithiazine to it, it changes color. So if we have a sample of material that's plugging a filter, we can take a sample of that material, drop it into one of these solutions, shake it up and go, oh, okay, we've got a dithiazine issue, rather than just I've got some dirt or other contamination in my pipeline. Very sensitive and very specific to dithiazine. For things like glove boxes, bioreactors, we have another line of oxygen analyzers for measuring trace level of oxygen all the way up to high concentrations. Basically an electrochemical cell-based oxygen analyzer that we can use in a number of fairly clean type applications. Big advantage is a continuously renewed sensor, so the next generation kind of ECAM sensors, and can be used in multiple applications. On the pipeline side, we look at what we refer to as the Praetorian. Trade name is a Praetorian. For those of you who are familiar, the Praetorian Guard guarded the emperor in Roman times. And the Praetorian is a fiber optic type device that can be put along a pipeline, can be put along a conveyor belt, and every 1/4 meter to 1/2 meter along the length of the fiber, we can use spectroscopic techniques to determine the strain that's on the fiber, the temperature at the point the fiber is, and vibration that's occurring within the fiber. So we do things with this like, as we try to show in this upper picture, put it along a conveyor belt. These conveyors have idlers that the conveyor belt is rolling along, and as those idlers wear, then they start to get damaged, they start to vibrate. And so we can use this to determine where along that entire length of conveyor lines, there's a potential for breakage in one of the idlers. And when those idlers break, and you shut down the conveyor, they can cause a fire. So we want to be aware of that. Same with along a natural gas pipeline or a liquids pipeline. We can run a length of fiber along there. From the strain, we can tell if the pipeline's settling and sagging. From the vibration, we can tell if there's a leak. With natural gas or things that we're going to get Joule-Thomson cooling, from the temperature changes, we can tell if we have a leak. So this fiber optic sensing device can be used to sense strain, vibration, and temperature. And from those, we can infer what's going along over long distances. We can install these over distances of 40 to 80 kilometers. And so we can measure along an entire length of a pipeline at, like I say, 1/4 meter, 1/2 meter intervals, what's going along the length of the pipeline. So we've seen, the big applications of this has been conveyor belts and pipelines. People have also wrapped these around large compressors and said, I want to know if I've got vibration in my compressor. On the natural gas side again, ZEGAZ is a chilled mirror type water and hydrocarbon dew point analyzer. So it can simultaneously do both the water dew point and the hydrocarbon dew point of a natural gas stream. It does this, it's not really a chilled mirror, but it's a chilled optical surface. Cools an optical surface as the gas is flowing over it. And when it hits the dew point, liquid starts to drop out on the surface. From the liquid's presence and using a spectroscopic technique, they can tell if that liquid is water or if it's hydrocarbons. So it allows us to do both of those dew points by the most accepted method for truly determining dew point, which is chilled mirror. I mean, that's what the National Bureau of Mines standard is. It is the method by which almost all other dew point analyzers get calibrated against. No moving parts, no consumables, first principle measurement, so it doesn't require calibration, operates at line pressure, so we have to do a minimal amount of sample conditioning, can be installed right at the pipeline. And I think we have a poll here too, Chelsea.
We do. 1 sec.
We're getting close to the end. I'm almost on time.
Oh, whoops, sorry. Yeah, that's right. We missed the COSA one last time.
Oh, my screen went up behind me.
Awesome. Okay, and we are probably good to end this poll.
I think so. Cool. Yeah, it's pretty clear. We've got two products there that are primary interest, so that's great. Directs us to where we want to go. A few more products to get through, and then we're going to wrap this up. Okay. Again, another AMETEK product that we work with is the BARDEN analytical oxygen analyzers. These are a quench fluorescence or an optical luminescence type oxygen analyzers. Again, you see this trend of us looking towards spectroscopic things. It allows us to make an oxygen measurement, again, with no moving parts, and it doesn't really have to chemically interact, if you like, in the same way as a lot of sensors do, like an electrochemical cell or anything like that, to make oxygen measurements. Very sensitive, down to parts per billion levels in liquids. So we can do oxygen boiler feed waters, for example, and down to single digit parts per million levels in gases. So common applications we'll see for these are oxygen levels in flare gas or in vapor recovery units. We've done oxygen measurements in actual hydrocarbon streams, like in propane, in crude oil. We've also used this as an oxygen measurement for leakage into tank blanketing applications. And so it's got almost no interferences and extremely resistant to most chemicals. There's a couple of things it doesn't like, which are aromatic hydrocarbons, but we've even done applications measuring oxygen in 55% H2S streams. Very chemically resistant, fast response, low detection limits, simple to install and operate. So, we show a sample system on the side, and this is one where there was actually were some of those things that would attack the sensor, those aromatic hydrocarbons that could attack the sensor. So you can see we've got switch scrubbing columns in front of it. They're going to get rid of the aromatics before it gets over to this oxygen sensor. And so it's a typical sample system we might put around that and integrate these systems. We've recently started working with the Xtrel mass spectrometry line, which is kind of a joy for me because when I did my graduate work in university, it was all on mass spectrometry. So we're proud to be able to work with Xtrel. These are probably the big name in process mass spectrometry. Everything from laboratory applications to, interestingly, a colleague of mine asked me to come out to see if I could help his son work on one. His son was working at the Canada Olympic Park Sports Training Clinic, and they were using the mass spectrometer there to do breath analysis of athletes and having some troubles with it. And so went in and did a bit of troubleshooting work with him. But fantastic product, able to detect almost any chemical. We see these being used on flare gas for BTU analysis now. We'll see these being used across a number of different process applications. Again, we're very common in ethylene plants. That universal analyzer's pi gas sampler was often used, pi gas samplers were often put in front of a mass spectrometer to keep all that particulate and steam away from the mass spec. We can have very low detection limits down to parts per trillion levels and extremely fast analysis time. Because of that fast analysis time, we can multi-point sample these. So we can put in valves that lets us have 16 or 32 sample points and just switch between the sample points and do that fast analysis. The Hawk asset monitoring equipment, a number of different types of this. The big one that has come out has been Hawkeye 365, but also the Connects 3Ds. And they allow us to put, if you like, almost like a mini SCADA system around a number of sensors. And so it lets us bring all that data together and make it web available. So if you have a tank farm, if you have an application where you've got a bunch of level or pressure transmitters that you want to be able to get data out remotely, these are small data acquisition systems with great software capabilities behind them that let us put a graphical interface around the things that you're trying to measure. So big applications of these will be tank farms and storage facilities, not stank farms, water and wastewater facilities, any place where we have multiple level measurements, agriculture, forestry, we're putting material to binnage. We want to be able to look at storage tanks and see levels. We can put that all around there. The 365 is kind of unique because it has support for multiple data protocols, RS-45, HART, Modbus, TCP/IP, cellular and Bluetooth connections. We can run all of these different signals together, bring it into one monitoring system, and put that available as a cloud-based monitoring system for you. One of the fun things, you know, I come from an R&D and product development background. So one of the fun things for us is looking for different things we can build. Seeing where somebody has a problem and saying, can we fix it? So the sample application was, we had a client who, they were pulling a sample, and when they were venting the pressure off of a propane line, they left the vent valve open. And they left the vent valve open to the flare header, and they left the propane truck attached. So they allowed all the propane in the propane truck to go to the flare header over a few days. So on the bottom right over there, see a valve with a spring on it. It's just like this one. And what it becomes is an automated return valve. So turn it, you want to make it vent, hold it open, let it go, shuts off automatically. We'll do those on two-way valves and three-way valves, and we put these all through sample systems now so that we can ensure if we want this valve to be in a specific position, a specific orientation for most of the times, and only be actuated when someone's holding it, it allows us to control that. We'll look at other products that you see up there. We've got the one that looks like a manifold up there is a probe that's going to sample and return to the same process, double block and bleeds on both sides. I talked about solvent flushing and cleaning sample cells automatically. So we have a solvent flush tank down there that we'll use in applications where we want to keep systems clean, where we want to back flush filters. We do a lot of things to try to make sure we do this right. Computational fluid dynamics modeling, 3D printing a prototype. So you see the one up there is printed in plastic because we want to see do all these parts go together. We're bringing out a line of sample probes in the near future. Just going to show one of them sort of here is a rendering of a sample probe that's going to go in the process. And we've got 3 NESI components on there. So we can do a probe that has integrated regulator, an isolation valve, coalescing filter, and regulator on it, all built into a probe that becomes customizable. We can change which components are on there. So we're always looking for opportunities where there's a problem and we can design and engineer a solution. So I think that one's got a poll associated with it as well, Chelsea, and then we're gonna get close to wrapping this up.
Yeah, this is one of the last guys.
Yep.
Okay.
It's kind of cool. We have interest across the board. All right. Well, I think I'm getting close to wrapping this up. Again, you know, we like to integrate solutions. So I'm just going to show some of the systems that we put together for different people. This is an animated, just a bunch of animated slides just showing installations we've done, whether it's for composite samplers, whether it's for, oh, did it stop on your screen? It stopped on mine.
Yes.
Oh, yeah, it doesn't want to animate it. Oh, there we go. Okay. These should animate through now. So again, like I say, we like to do systems integration projects. We've built a lot of panels for people, sample panels. We've built full shelters with analytical systems in them. See a toluene flush tank sitting over there beside one of our sample systems. We like to look at opportunities to try to build you a sample system that's going to do all the things that you're going to need to do and ensure that it can be done in a safe, reliable way and as easily as possible. It's one of my favorite pictures because it's got a whole bunch of our gear in it, 2 composite samplers. You can see an automated grab sampling system, solvent flush system towards the back, a JP3 infrared cell. And with that, that kind of wraps us up. I will mention, especially for my colleagues in Alberta here, we're finding it's difficult to get the ship beer, but we did do a great thing, I think, and we've actually got our own beer branded. So for anybody who comes by the shop for a visit, or if we can get out to come and see you guys, we're happy to bring along a 4-pack of beer and have a little discussion. We're going to put this on as a whole webinar series. Should be every 1 or 2 weeks, depending on my other training requirements. And we're going to basically try to cover products, applications, and opportunities. You'll be able to find all these webinars on Making Measurements Matter. If you guys are registered there, you're going to get invitations to all of these. As part of that ongoing series, we're scheduled to do one on level measurement with the Hawk instrumentation next week. And then we'll be doing one, says with COSA on February 4th. That's right, but I'm doing a training course then as well. We're going to make these individual ones now. So this one was kind of an overview. Our goal is now to try to dive into a bunch of these products, give you application details, information about the products, competitive advantages and disadvantages, where different products get used. If you're looking for any additional information, I put my contact information as well as Scott and Chris's up there. Chris, I'm sorry, I forgot to fix this side. Bob brought it up the last time and I did not fix it again. I'm sorry.
All good, man. All good. We got an E at the end of that. We'll take care of it.
Yeah. There we go. It's an E. Our new line card is out now, so you guys are going to get a copy of our new line card. And Jaden's on board here with us right now, and we will be getting a new website coming out at the end of January. Thanks again. Sorry for going over on my time. Any questions, happy to address them. And if not, have a great day.